Hello everyone. Today we will discuss some more issues in classification and regression trees. One of the issues is how to deal with categorical predictors. Okay. Especially nominal, because in ordinal at least you can have some order, but you can use the method that we are going to use now also. See, we said that in a tree every split is decided in something like this format. So you have to choose xj and you have to choose s, the threshold. So actually it's a lot of work. But for continuous predictor, it is comparatively easy because there will be some sort of pattern in it. Okay. So generally, because we want anyway binary split, so you know how to proceed, you know the direction. But in categorical predictor, so when I say you know direction, what I am saying is, if you decide that this is going to be threshold, then you know, okay, these are all going to left node, these are all going to right node. Okay, so you just have to keep moving the threshold. You don't have to do much. However, in the case of categorical predictor, what would happen? You have to try all possible combinations. Okay, so you can't actually say this is my category 1, this is my category 2, means say level 2, level 3. And you can't say, okay, I will shift my threshold from here to say here and then move these two to the left and remaining to right. Then try this combination where these two are to left and remaining to right. Just doing this much is not enough, because it may be possible that category 1, category 3 should go to left node and category 2 should go to right node with others. This is also possible, right? As a result, there are just too many combinations which we can decide, for going to left node and right node. Can you see exactly how many combinations are there? So let me consider a categorical predictor which has k levels or k categories. So if you have k levels, how many combinations are possible? So you have to divide these k levels into two groups. One is going to be the left group, other is going to be the right group. So how many possible combinations are there? Just give it a thought. Okay, perhaps someone is guessing 2 raised to k. At the first thought that sounds about right. Let us see. So for every level I have two choices. So for example, if I consider level 1, L1, it can go either to left node or to right node. Similarly, L2, it can go either to left node or to right node, and so on. And these are independent. If L1 goes to left node, that does not necessarily increase the chances of L2 going to left or right node. Okay, so they are independent. As a result, what I know is I have two choices for L1, two choices for L2, and so on till Lk. So I have 2 raised to k choices. But is this answer correct? Give it a bit more thought. Are there some possibilities which I want to avoid? Correct. See, one possibility is here all these levels ending up in left node. We don't want that. We want both the nodes to be non-empty, right? So I want to subtract that, and similarly I want to subtract the possibility of all of them being in right node also. So this 2 raised to k minus 2, okay, 2 raised to k minus 2, and there is some slight bit of more catch. See, suppose I have only 3 levels, L1, L2, L3. So the combinations that I have considered here, one combination would be L1 in one node, L2, L3 in another node. At the same time, L2, L3 here and L1 here is another combination. Okay, so this is combination 1, this is combination 2. But technically, are these two separate combinations? No, because what I am doing is, I am just calling this as left node and calling this as right node, but does it really matter? As long as my levels are not ordered, it doesn't really matter what is left and what is right. So even when I say this is left and this is right, basically these two combinations are giving me exact same split. So I don't want that. Okay, so I have to avoid all such repetition. So I have to divide by 2, right? Because every such combination is going to occur twice. So the total number of possible splits is 2 raised to k minus 2 upon 2. So basically 2 raised to k minus 1 minus 1. Okay. For a categorical predictor with k levels, the number of possibilities is 2 raised to k minus 1 minus 1, and it is quite difficult for an algorithm to handle this. So as k increases, for example, even if say k is 5, you have 5 levels, still you get 2 raised to k minus 1 means 2 raised to 4. So 15 possible combinations. So as k increases, the complexity increases. Okay. Hence, people started thinking, is there any way in which we can simplify this process? Okay. So what are the options that they thought of? In continuous scenario, things are easier because the values of xi's are ordered in some sense. So if you have a cutoff here, you just have to worry about moving the cutoff in one direction. So they thought, can something similar be done in categorical variable? And here is what they thought of as a solution. So let me first talk about classification setup. So I am in the classification setup means my y is, the response variable is categorical. Okay. So the error that I am going to measure is in terms of misclassification. Okay. And for the sake of simplicity, let me say y is binary response. Okay, y is binary response. So I have a categorical predictor, let us say x. I want to see how to arrange levels of x in such a way that choosing an optimal split would simply mean placing the threshold at the right level and then moving it in the left or right direction. Okay. So suppose there are 3 levels of x, L1, L2, L3. Now what I'll do is, we will compute probability of y being equal to say 1 when level of x is 1, when level of x is L2, and when level of x is L3. Okay. So we kind of find conditional probability of y equal to 1 given x is equal to L1, then conditional probability of y equal to 1 given x equal to L2, and conditional probability of y equal to 1 given x equal to L3. How do I do that? Quite simple. I have to just see for how many observations x is L1. If suppose I have 50 observations for which x is L1, out of those 50 I have to see for how many the value of y is 1. So if out of these 50, 30 I have y equal to 1 and remaining 20 have y equal to 0, then my proportion here becomes 3 by 5. The probability of y equal to 1 given that x equal to L1 becomes 3 by 5. For L2, suppose it is 1 by 5, and for L3, suppose it is 4 by 5. I am choosing the denominator 5 just for the sake of convenience, nothing else. Okay, it could very well be some other number. Now what do? We arrange these levels in such a way that probability of y equal to 1 is ordered, either decreasing or increasing. So if I want decreasing, I would have L3, then L1 and L2. Okay, because L3 had the highest value of probability y equal to 1, L1 had the second highest value of probability y equal to 1, and L2 had the least value of probability y equal to 1. Okay, and so what we are trying to do is, we are trying to put neighbors in terms of response together. Let me repeat what I am saying. See, because we have ordered the levels as per the proportion of y being equal to 1, those levels for which proportion of y equal to 1 is almost similar, they are put together. Okay, so the neighboring relationship is in terms of y. Okay, and that neighboring relationship is going to help us, because now what we will do, if L3 is something like this, if I arrange L3, L1, L2, now I will decide threshold just by moving. So one possibility, I would keep L3 in one class, L1, L2 in another class. Another possibility is I move my threshold here, so L3, L1 here and L2 here. Okay, so I have to consider only two possibilities. So in general, initially we said we will have to consider 2 raised to k minus 1 minus 1. But here, if I am going to order the levels, so ordered level 1, ordered level 2 and ordered level k, then I have to worry about putting my threshold here or here, so between each of them only. I don't have to worry about other places. So how many choices do I have? Only k minus 1. Okay. So I won't allow the possibility of OL1 and OL3 being in same class and OL2 and remaining being in another class. Why? Because now I have ordered these as per the response, so the neighbors should stay together. So OL1 and OL2 are neighbors, OL2 and OL3 are neighbors, but OL1 and OL3 are not neighbors unless you bring in OL2 also. Okay, so such combinations that we need to check are eliminated, and as a result we will have drastic reduction in the number of comparisons. So from 2 raised to k minus 1 minus 1, we are reaching k minus 1. Try for k equal to 6. So if I have k equal to 6, I have 2 raised to 5 minus 1. So 2 raised to 5 is 64 minus 1, so 63. Whereas here I have just 5. See, I mean the dramatic reduction in computational efforts, and of course that would make your algorithm faster. Is it okay? This is how you handle categorical predictors in trees. Okay. So what to do if my y is continuous? If my y is continuous, I have to just change the things slightly. So if y is continuous, what I'll do is for every level L1, L2, L3, I would compute kind of conditional mean of y for that level. Okay, so what is the mean of y when level is 1? What is when level of x is 1? What is the mean of y when level of x is 2? And what is the mean of y when level of x is 3? So if it is say 0.8, 1.9 and 1.1, then I would arrange as L2, L3, L1. So again in the order of conditional mean of y. So again depending on y, I would decide which levels are neighbors and I would do the exact same exercise. Okay. So let me stop here. Thank you.